Hello, my name's KJ. I work at Zendesk on our kind of big Rails monolith team. So yes, I help keep the thing fed and watered, basically. I'm also newly a committer to Ruby, the language, which is kind of new and exciting. And you get to poke around in there and find all the dark, disgusting parts of the C code base. So that's a bit of fun. And I'm here today because I promised someone, and I don't even remember who, 2 months ago at the last meetup that, oh yeah, you're interested in this fiber stuff, I'll talk about it. And thus, here I am talking about fibers. So oh yes, this will be kind of interactive. So I'm going to be asking questions. Please feel free to interject at any time. If I sit here uninterrupted and talk for half an hour, I will consider that a drastic failure. So it is on you to help me avoid failure. What are fibers? All right, taking notes here. Someone throw me an answer. What do we think fibers are? They make your t-shirt. And in what way do they make your t-shirt? All right, I kind of like that analogy. We'll see if we can use that. Anything more computer science-y, perhaps? Event loop? That is an interesting idea that is definitely related. Virtual threads? All right. Fiber optic cables. Not that kind of fiber, unfortunately. I'm going to put up here. Sorry? Okay. I'm going to write the word coroutines up there. Does that vibe with anyone? Yes, that is excellent. You're skipping to the end of the talk. I promise we'll come back to that. Yes. So let's unpack this idea of a coroutine. And before we talk about what a coroutine is, let me ask you, do we know what a subroutine is? Yes?
What is routine?
So if we think of a routine as just like a piece of code we want to run, then a subroutine, aka a function, method, block, I don't know, any other names I'm missing for it? Just the things you know as functions or methods, basically, are also called subroutines in some programming languages. And it's called a subroutine because it runs a piece of code kind of in between your other code. So is anyone going to be very surprised at what this prints? Right? Like, who thinks they know what this prints? Yes. Okay, I'll print it. Okay. This is not terribly revolutionary for most people, I would think. Yeah, whoa, it's a function call. You're here, then you go into the subroutine. So you start the subroutine and you finish it with the return, and you're back here where you started. And if I was to draw that in a little picture, do I need to share, or is that big enough? It's probably big enough, right? Yeah, we can see that. If I was to draw that in a little picture, we can see like we're running the script, and then we're going to stop running the script and run this other function for a bit. And then when that finishes, we're going to go back to running the script. That sounds pretty reasonable to everyone. All right. So we noticed this returns once, right? This function. What do we think this is going to do? Oh, I need to make this go away because it's stealing half of my screen real estate. There we go. Yep. Right. Bingo. It's going to print this bit twice because the first time it's going to go here and then return. And the second time, it's also going to start here and return. And if I run it, ta-da, what you said. It's going to run once and then run again once. Now, what if we wanted this program to actually print this? Can we think of any way that we could make this happen? And what I mean by this, let me maybe go here. We've got this coroutine, if you can still see that. I'm going to call it a coroutine, where it's got return 1 and return 2. And the first time we call it, we want it to return 1. And then the second time we call it, we want it to kind of resume halfway and return 2. How do we think we can achieve this? Don't say fibers, because that's obviously the answer. But how can we do this without fibers? You are pretty much right.
I was going with the enums, but
Okay, you're both pretty much where I was going. So yes, we could pass a block to my coroutine and do this yield thing, right? And if we did this, this is going to print this every time we call yield in the function, it's going to call back into the block that we provided. So what this will print is it'll print kind of value 1, value 2. Nope, that's not the right function. Yes, that'll print value 1 and value 2, and then the astute people will realize that, oh, this is not printing the same thing that the previous script ran, because it said first set value, second value here. So if we want to make it do that, then I heard someone say global variable, and I heard you say switch case. Sorry, I need to make this smaller now, don't I? Oh, yeah, is that legible still? Yeah. So we can do something like this, right? Where every time the function is called, every time our block is called, we kind of remember where we were at, so that the next time round, we'll go back and run the second value. And what that ends up looking like is kind of something like this, right? Okay, that is pretty small. Let's maybe show that slide. What that ends up looking like is kind of something like that, where we're going to call, like, the coroutine, the function, the my coroutine function is going to yield, and then it's going to yield the block again. And the problem with this is that we still, no matter what we try, have this nested structure, right? Where this calls and it doesn't keep going until everything to the right of it's finished. This calls, that's not what I wanted. This, my mouse, yes, calls here, and it doesn't keep going until everything to the right of it is finished. So we've built this kind of nesting, and that's not compatible with what we wanted to do here, which is to unnest it. And this kind of unnesting is basically what fibers are for. Yes.
what about lazy enumerators?
Actually, under the hood, use fibers. So again, jump into the end. But yes. So where were we? Yes. Okay, so we can rewrite this with fibers by doing something like this. We take our yield, and instead of yield, we write this magical fiber.yield. And instead of calling the function, we're going to write fiber.resume. And this program is going to kind of enter here first time, but it's going to second time. And because I'm not a liar, if I run this program, it should print what we're looking for. I hope I'm not a liar. It's that number 8. Yes, well, I would not be the first person to have live demo issues on stage. Yes, there we go. We see entering coroutine, value 1, and then exiting coroutine, value 2. So basically, what we've done is we've managed to find a way with this second f resume to start executing the function from the middle instead of executing the function from the top. And because of that, we end up with a control flow that looks like that. Should have made this one bigger. Sorry if you have to squint. But it's where we, instead of call, we're going to refer to call as resume, and instead of yield, instead of return, we're going to say yield. Yes. Please.
Is the benefit of doing this like faster performance?
Eventually, yes. Jumping ahead. No, that is a good question. The benefit of doing this, you're right. This is, as written, like really stupid code. And it does not at all make it easier to read your code if half of the time your functions start from the middle rather than the top. So this is a tool that lets us build different things that look better. Yes.
What happens if you call it a third time?
I think it will crash, but why don't we find out? See, this is why I didn't put this on the slide, because I wanted to be able to do that. I think it raises a fiber error. Let's find out. Huh. Or it just does nothing. Okay, the third time it returns nil, and the fourth time it raises a fiber error. Yes. So if I said puts the third time, this will happen the third time then, won't it? Yeah, okay. So what will happen at the end is you'll if you try and yield a fiber, but you've already got to the end of it, it raises that exception. But yes, let's ask the question, what the heck is the point of all of this? And yes, we can use this as a building block to get better performance. Any other thoughts?
Increase complexity.
You can definitely do that. All right. I am going to introduce a terrible hack, which I had cause to use fibers for. And before I do that, I think let me introduce my job a little bit. So yes, I need a drink to talk about it. I mentioned I work on Zendesk's, million line monolith, and it accretes 15 years of code that does various things, and it makes too much money to turn off and makes too much money to break apart. So thus the monolith remains, and thus I keep it running. And so I would not really call myself a developer. I am a hacker. My job is to take square pegs and try and whack them into round holes so that this 15-year-old code base keeps on going, which is not to say that it's a terrible job. I love doing it. It's a fun puzzle. It has real value. Like, this code exists because it solves millions of customer support inquiries every day, and it's useful, and that's why it's still there. But it does mean that sometimes you have to do a bit of archaeology and make things fit where they didn't fit necessarily. So who here is familiar with the idea of block-based resource management? I think you will be when I don't call it that. Basically, the idea is to, you've got some resource, like a database connection or a temporary file, or I don't know, out of ideas.
Sockets?
Socket, yes, a socket. There we go. Thank you. My plant helped me out here. You've got some resource that you really want to make sure is cleaned up, right? You want to make sure your database connections are closed when you're done with them. You want to make sure your sockets are closed when you're done with them. You want to make sure your temporary files are deleted when you don't need them anymore. And so obviously, if you just have the resource and throw an exception, you might forget to clean it up. You need to put sort of the ensure block in there and make sure you call close and handle all the errors. But to make this easy, lots and lots of APIs. For example, this is the temp file one that I shamelessly copied out of the Ruby docs. Instead of giving you a resource, you give it a block and it calls the block with the resource. And then it makes sure when your block ends, your resource is cleaned up. And this would probably make more sense than that inane rambling if I just show you the code. It's like if you have a temp file and you create it in the block, the file exists, and then not in the block, the file is gone. Ruby has cleaned it up here. If I run this number 11. Okay. The thing is cleaned up, and this is all sorts of things. I think the example I'm thinking about involved Redis connections have this kind of pattern where you get them in a block and they're cleaned up outside of the block. But I mentioned that my job is whacking pieces of code together that don't fit and bending them into shape so that they fit. And there are sometimes circumstances where it's very difficult to actually use the block-based form of these methods. So mini-test, are people familiar with mini-test? It's the default Rails testing framework. There's really not much to explain. You make methods called test, the mini-test runs them, thus you have a test. So if we have this test and run this test, it's going to create a temp file test. You have to take my word for it. There we go. It blends and it made a temp file. And then because I'm a good developer and I write tests for all my code, I wrote a second test. And this test also needs a temp file. And then someone tells me in my PR review, they're like, KJ, this code sucks. You should extract that temp file logic because you've done the same thing twice in 2 different methods. And then I go to the Minitest docs and I find out you get a method called setup and teardown. So Minitest runs setup before your tests and it runs teardown after your tests. And this is great. I think I can put the temp file logic in setup and the cleanup logic in teardown, but there is no setup and teardown logic. I have a block I need to call. So how do we think we can, I guess, not really a spoiler to say the answer involves fibers, but how do we think we can use fibers to bang this code into shape to be able to use the block-based form of temp file create here, even though we're not running in the right context? Because if I do this, right? And I say, okay, let's save this file in the setup method. This file will get created and then immediately deleted before the test runs. So this is not going to do what we want. All right. Give 2 more seconds. Okay, yes, you open your mouth.
It's slow. Sorry.
All right.
But if you created that block elsewhere that gave you yielding points, then you could call the yield points. Okay,
Is this what you were thinking of?
yeah, I mean, that wasn't quite as concrete, but yeah.
Okay. Okay. So what we learned about fibers is that they're functions that we can start and then kind of park off to the side and we can come back to them later and resume from the middle instead of from the top. So if we think we've got this block of code, which is temp file create, what if we start running this block of code and then park it here while the temp file exists and steal the temp file out of the block. And then when we want to close the temp file, we'll resume it. And so it keeps going to the end. So the idea here is basically you, well, I'm not going to repeat myself. The idea is what I said. So you'll, yeah. Actually, I'm going to shut up and let people absorb this for like 2 minutes. Well, not 2 minutes. That'd be very awkward. But... yeah, it's overly clever and complicated.
How do you use it?
So when we call fiber resume here the first time, this will start the fiber. It'll go into here, temp file create. Then it'll end up here. And then because this is the first yield point, that's where we stop this fiber and keep going in the main test thread. And we run our tests. Then when we want to tear down, we kind of resume the fiber. So it goes from here and then runs to the end, thus deleting the file. Such hacks. Right. So we can see in setup makes the temp file. That's printed there. Then it does the test. Then it says closing the temp file. And this is not a good idea, but so it is an idea. That sometimes it's a tool in the toolbox that can be reached for. Yes.
If the process like not killed but like exited before the teardown is called, will it close the file?
So what you're asking is equivalent to this question. And where is the file that I just created? Let us find out. So you're saying f equals fiber.new do, and then begin that. Ensure what's yes, I promised I cleaned up. And then if we do this, we are pretty sure this is going to clean up, right? Because we're resuming it up to here and then resuming it from there to the end.
I mean, it will, but whatever.
It's not the same thing. I'm just confirming this before we go any further. What did I call this file? Fiber teardown. Okay, so now the question is, if we don't do that, Does it still clean up after itself? No, is the answer.
Testing different things. You're testing whether or not it runs in shore block after, not whether or not a garbage collected. But although if the garbage collector temp file, yeah, it would get shut down. Could you create a temp file, check its path, and see if that path exists after it shuts down?
So the garbage collector may actually well run the finalizers, but that doesn't necessarily mean the ensure blocks will run. And it's very common to put resource cleanup for things that are not in the standard library in ensure blocks, and exceedingly uncommon to define their cleanup in finalizers. So yes, the garbage collector for very specific kinds of objects that have finalizers registered will clean them up, but it's, in my experience, very uncommon. And if you skip these ensure blocks, you will probably leak whatever is supposed to be insured. Cool. So that is one good reason why I didn't end up putting this into production. But where am I up to here? No, I found another way around it. Stay tuned for my RubyConf AU talk proposal, which I submitted. We'll see. Yes.
This that you where you yield it to the thread before it's completed the work that it needs. I don't know, maybe I'm wrong, because it feels like if you're yielding and then consuming the thread, you potentially have problems with the block.
So the reason why that is not a problem is because the yielding and resuming is happening by the thing that is being yielded. So with threads, right?
Yeah.
With threads, they can be stopped at any time. The operating system says, you've run long enough. Off you go. No more CPU for you. We're going to run this thread instead. So whatever that thread is doing, it has to set itself up in a way that it can be safely interrupted, or it can be safely used by another process. And this is why you need things like mutexes and whatever to protect shared state when you use threads. But with fibers, they only stop running when they have a yield statement. So
effectively, threads are working within the same thread as, sorry, fibers are working within the same context as the thread you run.
In Ruby, fibers only run in the same thread. Yes. So it is, whilst you're in here, if I did, a equals 1 and then a equals a plus 1, there is no possible program without using threads that will see a value of a equals 1. Is what we're saying there. Yes. All right. So I shared a bunch of stuff about fibers and like weird ways you can bend control flow with fibers. And we kind of all laughed and said, that's a terrible idea. Why would anyone ever want to do that? And that is true. But we have this idea here of a computation which can be suspended and resumed. So the reason why people call them lightweight threads, or why they have anything at all to do with concurrency, is that it's possible to, okay, I phrased this as a question in the slide. The question is, what if fibers suspended themselves while waiting for IO and then will resume when the IO is ready? So the fiber could know that it's waiting for something, and then we can run a different fiber and then go back to that fiber when the waiting is done. And, because that is a computation that is running, waiting, and then continues running. It's not running, waiting, and then go back to the top. And Ruby 3.0 introduced 2 features, basically, that make this possible and realistic and useful, called fiber scheduler and fiber.transfer. I am going to briefly just show you that these APIs exist, but don't feel too concerned if this blows past you, because in reality, these have been wrapped up very nicely by gems. So you'll never use these APIs directly. But just for argument's sake, what the fiber scheduler does, sorry, actually, before I do that, by default, if you do IO in a fiber, that fiber is going to block waiting for that IO, and nothing else will run. Because if you write something like that, fiber.yield API.get, that's it. Okay.
I'm not doing anything. I'm just
Uh,
looking at your screen.
This program is going to take 6 seconds to run, as in both of the waits happen in sequence, as you can see here. It actually takes longer than 6 seconds because this API is really slow for some reason, but it took longer than 3 seconds. So this fiber.yield is not powerful enough to model, hey, I want to wait for the result of this IO and then keep going. But that is what the fiber scheduler lets us do. So if you, or more likely the gem you're using, calls fiber.setScheduler, basically you can provide a bunch of callbacks to Ruby, which Ruby will run when certain events happen. So with this one, when we call API.get and Ruby realizes that, okay, I've got to wait for some network traffic to come back before we can keep going. Instead of just sitting there waiting, what it actually does is call the fiber scheduler in the hope that the fiber scheduler might find a different fiber to run. So if I run this, yeah, we started the fiber and then we did an API call and then it said, aha, the fiber scheduler got called because this API call was blocking. And what a real fiber scheduler should do in response to this is find a different fiber that can run. And what this fiber scheduler does is exit, because that's more than code that can fit in the screen. But this is kind of the Ruby language is helping, is basically making fiber blocking something that can be controlled by a gem. And the other thing that Ruby added is fiber.transfer. Whereas if you think of fiber.yield as calling a function, sorry, fiber.resume as calling a function, and fiber.yield as returning from a function, fiber.transfer is basically goto. So this program, for example, has 3 fibers. That's going to be bad. And F1 calls F2, which calls F3, which then calls F1 again, which is not a program structure you can make with call and return. You can't function call into a loop like that. Functions have to call and then return. They can't call and return and then be called again in a loop like that. So this fiber transfer basically lets the fiber scheduler kind of just pick a different fiber and run it without having to worry about where it came from. But as I said, actually, any questions about that? Yes.
Does it like jump the fiber and don't continue its own fiber?
Yes.
So it's not like again in your blog that it's finishes the say second fiber and it just the end of the second fiber.
Correct. Once we transfer here,
Yes,
nothing will ever return back here.
go to.
It's literally go to, yes. So this will never happen, I think, if I've written this program properly. Yes, you don't see that.
So the reason why you put the async request in the yield or after the yield could be any other line.
Is this for this example?
Yeah, like what if you had five whatever? Next line API don't get next line.
Okay, so let us do this. So you're saying fiber.yield. I guess we'll get the response here. So we're saying we want to do that. So this will seed control twice, right? So the problem that you're going to run into here, I see you're trying to come up with a way to do have the waiting happen in parallel, right?
Just trying to see waits between.
So if you, is this the example program you want to write? Yes, okay. So we're gonna call fiber.resume.
Start the request.
Yes. And then we're saying we want to do that. I'm open to any other program you want to write. You can even come up here and type if you like. So this is still going to take 6 seconds. Oh, it's going to take 0 seconds because I can't type. Starting fiber two, oh yeah, okay. So, right. I mean, this resume, this is what this returns is the result of that yield. So if we have to return something here, right? So yeah, it never actually ran the second request here because we only resumed fiber two once. We only executed it to here. Didn't even start the request. If we want to run the request, we have to call resume again so that it gets to that line, but then it won't return until we get to there. So you can't make anything happen in parallel without cooperation of the fiber scheduler. The fiber scheduler is what makes the do the waiting in parallel possible, because that is Ruby, the language, detecting that this would block, and instead of blocking, I am going to call the fiber scheduler to switch to a different fiber. That's the language support that's needed. This cannot be done without language support. Is that a bit clearer?
So what will it do when it hits the 8-9 gap and it's blocking for those 3 seconds? Where will it go?
With the fiber scheduler or without the fiber scheduler? The fiber scheduler must choose a different fiber to run. And if it doesn't, then it can sleep.
Doesn't matter whether it's after the yield or whether it's
So normally with fiber scheduler code, you won't explicitly yield. I'll demonstrate this in a second.
Is fiber scheduler creating fibers?
No.
So is it finding-
Excellent question. All right. I need to go to the next slide for this. You will never use write a fiber scheduler yourself, almost certainly. It would be completely pointless because this guy has written the best one you could possibly imagine. That's Samuel Williams. He gave a talk about this at RubyConf last year. You should listen to him talk about it, not me, because he wrote the damn thing over several years. Like, he got a lot of the support for fiber transfer, for fiber scheduler into Ruby in the first place, so that the async gem could use it. But async is kind of the fiber schedule implementation you will normally use. So the way you would write a program with async. So here's our example where we want to call httpin.org twice in parallel, and it should take 3, not 6 seconds. Actually, instead of creating fibers yourself, you tell async to. So you say async do, and that tells async about this task that you want to run. And lo and behold, this should start this task, then wait for this, and then wait for this. So this should only take half the time because it can do both of the waitings at the same time. And then again, if I don't have any bundler problems this time, I'll go away. Oh, I know why. It's because I'm not using 3.3. Anyway, it's fine. So yeah, this program took, what's that? 17, 21, 4 and a bit seconds. It didn't wait in series, it waited in parallel. And you didn't you didn't write the word fiber, but we uncomment that. We can see async created 2 different fibers. It created this fiber to run one request in, and this fiber to run another request in. And we also didn't write the word yield in here at all, because actually the yielding happens implicitly when we're blocked on IO. So when you're using fiber scheduler, Ruby kind of automatically decides to call yield in your fiber when your fiber is doing something that needs IO, if that makes sense. There's like, where did I put the docs for this? Yes. A very rich set of, primitives that you've got here. So like, I think async's got a thing for example, right, you can start a limited number of tasks. So you can say, all right, I want to process 100 requests, but only 2 at a time, so I don't melt my servers, and then async can help with that. You can make barriers to be like, all right, do this set of tasks, wait for them all to finish, then start the next set of tasks, or barriers that wait only for the first n tasks. So whatever, all the kind of organizational needs are taken care of by the async gem. So you kind of describe the rules for how you want your program's concurrency to behave, and you don't have to worry about writing explicitly fiber yield here or using threads and stuff like that. Anyway, I don't want to, obviously you can write amazing programs with async, but I'm not going to sit here and go through the whole API. Mostly the point I wanted to get across here. What is the point I wanted to get across? All right. Point I wanted to get across, and then I'll take more questions about this. I don't know if any of you have read this "What color is your function" blog post. I think it's quite famous, but it's a pretty easy thing to Google. What color is your function? But the idea is, with fibers, we write beautiful concurrent code that starts. I'll go away. I want to highlight something. Starts from the top and kind of reads the top down. The order the code is laid out on the page here is the order that your code is running. If you are familiar with the wonderful world of JavaScript, and especially the wonderful world of JavaScript, 10 years ago before async and await, you might be familiar with this idea of callbacks, where you start something and then you kind of keep executing, and then later on your callback runs. So you read this code and it's backwards, or look like a Christmas tree, or like, and async and await kind of solve that problem. At least it means your code's not a Christmas tree, but it does still mean that a function is either an async function or not an async function. Whereas with fibers, all functions are the same. And I think like there's a good Ruby example of this. Maybe there's a good Ruby example of this. No, we're not taking away anything yet. Has anyone here had the misfortune, the deep misfortune of using Event Machine? You have? Dear Lord. Okay. For the rest of you, you are lucky. You have dodged a major bullet here. But some people in like 2000 and 2010, you use Event Machine?
Yes, PHP.
Is there a PHP version of Event Machine? Jesus. I mean, I'm sure it's got all the same problems.
That's what is I left the PHP.
So is it from 2010? I don't know when Event Machine started. It's definitely like of that era. Some people thought that we should be able to do async in Ruby, and we didn't have the fiber scheduler at the time. And so what they did is they made Event Machine, where you write Ruby as if it was JavaScript circa about that era. So instead of saying requests.get and then the line after that, you do requests and then callback. When the request runs, we need to call this code. So, the code keeps running, and eventually we'll call back into here later. And then, like, notice that. And maybe piss off. Yep. So the execution is backwards. And that's only the first thing that sucks about Event Machine, actually. This I could deal with, like, for the sake of performance, if it was made my code better. But the worst part of this is that you have to use this. You have to use em HTTP request. If you just like say, Faraday.get or net HTTP in here, etc. This is going to lock the reactor up for like 3 seconds while you do this request, and nothing else, no other callbacks, no other work can possibly happen concurrently with that. Event Machine needs to know about all of the IO in the program so that it can appropriately sequence that. And it leads to this like really annoying bifurcation in the community. So I have very vivid memories, and Ryan McGuire is not here. I worked with him at Style, and there were two RabbitMQ clients in Ruby at the time. There was one that used Event Machine and one that didn't use Event Machine. And for whatever reason, we needed some feature that was only in the Event Machine one. And so this Event Machine shit just polluted our app because we needed this library. So it kind of splits the language in two. There's the Event Machine language, and there's I don't know if there's anything else like Event Machine, but if anyone else wrote a similar system, Celluloid maybe, there's like the Celluloid gems, and they're different from the Event Machine gems, and they're different from the standard gems. The beautiful thing about the fiber scheduler is that because we're waiting on IO here, let's do something else, is handled by the language, it knows about all the IO. And so you don't have to like have a whole ecosystem of things that work with one library or another. If I write my code with async today and I decide tomorrow to use a different fiber scheduler or no fiber scheduler at all, go back to threads, I can do that by only changing like the very top parts of my program that call async. All of the bottom parts of your program that do a thing, wait, do another thing, wait, kind of look the same in all frameworks. Any questions about that?
So there could be only one fiber scheduler in place, right?
I thought that too, but I gave this talk with some work colleagues this morning, and someone asked me that question, and then I looked it up, and that's actually not true. You can have one fiber scheduler per thread. So I don't know of anyone that's because fibers in Ruby only are currently pinned to a thread. I would actually like to experiment with migrating fibers between threads, but that's not a thing that Ruby supports at the moment.
So you can't call fibers cross threads?
I don't believe so. No, I think we were talking about this program. That I think you can do. Because the thread kind of is detached and off on its own. But this is the question. Fiber equals fiber.new do. And sleep one, wait for the fiber to appear. Okay, and then do we think this program is going to work? Is that our question? I think the answer is this is throw an exception, but let's find out. What do I call this? Yeah, fiber called across threads. So you can't do that. And that is probably why it makes sense to be able to have a fiber scheduler per thread. But I don't know why you would do that.
Rather than the scheduler running those extra fibers in, like, say, separate threads, it's something at a much lower level that just knows to just continue moving.
So I think what you're asking, and please stop me if this is not at all useful to you.
Can you repeat questions for someone?
Oh, sorry. Yes. All right. Let me answer this question and then I'll check Zoom. Oh, sorry. To repeat the question.
Yes.
So the question was, I think I know how to answer the question, but I don't know what the question was. Let me answer the question that I think you asked. And then you can tell me if this was at all useful. Yes. Okay. So when you do IO in Ruby, you call io.read or file.read or socket.read or whatever. Eventually, it'll probably go down into this function called rbio_wait inside the interpreter. And this literally does, okay, is there a fiber scheduler? If so, call the fiber scheduler and we're done here. And only if there's not a fiber scheduler does it go and do things like, what is the file descriptor we're waiting for? Call select or poll to wait for the file descriptor to be ready and then, go back and keep running. It is the fiber scheduler's responsibility to actually keep track of what IOs are being waited on by what fibers. So async uses, I think uses a separate gem also by Samuel called event IO or IO event or something. But what that is basically a wrapper around the select or poll system calls or IO uring on Linux or KQ on Mac OS and BSD. And these are APIs that let you say, hey, I'm interested in the results of this file, and please ping me when one of them is ready to be read. And then the fiber scheduler can kind of block doing that. And then when one of them is ready, it's like, boom, this file is ready. So we got to resume that fiber that wanted that file. Is that at all the question you asked? Okay, what was the question you asked?
But I think my brain's managing to process through the answer. So essentially, the way I was kind of thinking about it is he's kind of thinking in the perspective of like a thread versus a raptor, right? right? Like, if you set a variable and then something goes passed off to the scheduler and then that variable was somehow changed, what's the scheduler going to see? Is it? But I actually can't now thinking about it. I'm not even sure if that could occur.
The scheduler gets called as a result of IO.
Yeah.
So the scheduler gets called, like it's in the same call stack as, file.read, some Ruby stuff, then the scheduler is called, and the scheduler will respond to that by calling probably, okay, IO Uring, or okay, epoll, let's also keep an eye on this file, and then transfer to a different file.
Do you have that example we had before where there were two fibers being created and they basically waited on the scheduler? I think it was the first time you introduced the scheduler.
Yes.
Yeah.
So
So then
the way, what,
the actual code that's running, so we got to the fiber 1 and fiber 2.
there's only one fiber in this example.
Oh, there's only one fiber. Yeah, wait, hang on, wait.
This one didn't wait. I just called exit. Because to actually implement the waiting here, what you would need to do is something like,
So does the fiber have access to the variables that exist outside of the fiber?
it'll have access to globals and like instance variables and stuff that anything would have access to.
And I think, and correct me if I was wrong, but I think, maybe it was it async where they both run and you tell it to wait.
Yes, that's async.
Right.
So that is async implements the fiber scheduler interface
Yeah.
so that this works.
Or task 1, and then modified it. I don't know, let's just say after task 2. Is it possible that then that the value of that variable is different inside of one of the async tasks depending on when?
Is this what we're asking?
Yeah, essentially in that 3-second delay, if you change that value but outside of the async block. So just change it there. I'll need it active inside of the async after it's waited 3 seconds.
This will be immediately visible. This will be visible in here. Because this is sharing a binding, I think, with up here. Okay.
Because obviously without a fiber, you couldn't really get yourself to that position.
Well, you can do it with threads.
After.
So actually, yes. So the beauty where you do have this kind of state with fibers, because fibers only yield when you do something to cause them to yield by doing IO or by calling fiber.yield, you can very safely manipulate shared variables like this in the full knowledge that only you are accessing them, unless you have other threads. So it kind of makes this is completely defined. It will either be task 1 or 2, but they're the only things it can be. There can't be any weird in between states because only one of these two will finish in some defined order. And yes.
But what if they modify the first variable, like inside their symbol?
That will be visible, like this, right?
Yes. No, but what if you remove the if statement on line 14 and the if statement on line 20?
Oh, well, it'll just be whichever one finishes last.
Yeah, but what if you use singleton class that simplifies it? Because last will be the local variable price.
Yes.
But is it will be scoped to the async or to the line 10?
It's all the same.
It's the same binding. It'll be this. It'll be the same variable. This will print either task 1 or task 2.
Yeah.
Yeah, I mean, in a real program, you'll probably, my thing.call and not share a binding. And then we're back to normal Ruby things like be careful with mutating instance variables. So writing your entire program in one binding is not good in any framework. All right, how are we doing for time? Oh, hang on, I have 2 questions here before I begin wrapping up. Looks like Event Machine is dead. Thank God. Serial load under wholesale update challenge, but also looking dead. Praise be. Hope I never see it again. Cool. I think so. It does the same thing, but just much better. Like you can do all the beautiful things in parallel that Cellular or Event Machine can do, except with the same libraries.
If we go back to the lazy process,
Oh, yes. So enumerator is actually implemented with fibers in Ruby.
but lazy enumerators existed before fibers.
Enumerator.next is implemented with fibers in Ruby. Lazy enumerators do not. Let's talk about this afterwards, because this took me a little bit to unpick as well. But lazy enumerators don't need suspension and resumption, because the enumerator calls through to the next thing. So it's actually a deep call stack. It's only when you have enumerator.next where you've got some enumerator and you're like, give me the next one, do some stuff, give me the next one, do some stuff. That is where you actually need to suspend the context of that block. And that only came in Ruby 1.9 with fibers. I think fibers were in 1.9.
That was like twisted.
No, fibers have been in Ruby for yonks. They were originally put in Ruby so that you could do this kind of control flow, so that so you could do this kind of control flow pretty much to implement enumerator.next is my understanding, or because someone felt like it. A lot of early Ruby stuff is there just because someone felt like it.
So what was it that came in Ruby 3?
Fiber scheduler. So what came with Ruby 3 are the tools to make fibers useful for IO. But fibers for twisted convoluted control flow have existed for quite a while. All right.
So in the JavaScript, when you have a fetch request and it presents a promise, or you can make your own promise. Is there a similar concept of API.get is an IO blocking thing? You know that'll yield. But what about, can you create your own sort of async thing that will?
No, if you want something to be visible to the fiber scheduler, it must be done. So the question is, sorry, the question was, can you write kind of custom promise implementations to wait for IO that Ruby doesn't know about? And the answer is no, Ruby must know about the IO, which means it has to be done eventually through one of the base classes like socket, file, whatever. If you use a C extension or something to like go and do IO behind its back, well, it can't know about that, and it doesn't. And this is why you can't use async with the MySQL 2 gem. Because, I mean, you can use it, but it won't do anything useful because the MySQL 2 gem does all its IO in C in a way that the fiber scheduler doesn't know about.
That one reasons why it's being placed.
Yes. Trilogy?
Trilogy.
Yes. So Trilogy is, I don't know if it's written in pure Ruby. Okay, so because it's written in pure Ruby, Ruby is aware of all of its IO. And so it can use the fiber scheduler.
And the extension.
And YJIT. All right, let us continue this conversation. Yes?
You also not bringing the breakfast thing in this?
Am I not supposed to wind it up at this point?
Here's a question from.
Oh, sorry, I missed that. I mean, I can sit here and talk about this, but
Like
Alright.
use of actors.
what's your take on Raptors for concurrent stuff? This is recorded. Ask me afterwards. Yeah, if I was back to 1.9 at least. Okay, so my non-silly take on Raptors is, yes, he can't ask me afterwards. So the point of Raptors, as written by Koichi, sorry, can I just pause the recording? No. Let me be, polite to people here. Well, not polite, but like take the generous interpretation here. The point of Raptors, as I have understood it, as implemented by Koichi, is that they allow you to run Ruby code in parallel. Because normally you cannot run 2 Ruby threads at the same time. If you have 10,000 Ruby threads in your program, Ruby will run one, then run a different one, then run a different one. But you'll never have 2 CPUs with 2 threads of your program running on them at the same time. Because Ruby has like a global value, or global VM lock, I think it's called. Because mountains and mountains of internal Ruby data structures are just not thread safe. The garbage collector is not thread safe. The method resolution like sets caches in ways that aren't thread safe. I know the Python people have started doing a lot of work in removing the global interpreter lock in Python, and it turned out to make it slower because you have to add so many more locks. So Raptors are a way to kind of carve out an island of Ruby where it's guaranteed and not to mutate any shared state. So you're not allowed to set global variables in Raptors. You're not allowed to set class instance variables in Raptors. The only data you can get from Raptors is either data that's frozen or data that's passed to you through raptor.send. And then it kind of is disowned from the calling thread and now is owned by your Raptor. And because of this, it now has a limited form of parallelism. So two Raptors can run on two CPUs at the same time doing Ruby code. It's not full parallelism because, for example, the GC is completely single-threaded, but it is some parallelism. The problem is, I think, like, if you're writing new things that want to process data in parallel, and I think that's kind of the use case that Koichi had for Raptors, like, this is quite good. If you own a million lines of legacy Ruby, there is no way on God's green earth that you could ever comply with those restrictions. Like, all right, probably cannot write globals, but we'll write globals with singletons and stuff all the time. And so, the holy grail would be to have a version of Puma that ran every request in its own Raptor, and then your request can run in parallel and it's magic and fast. But I think we're just a very long way away from being able, like, from the mountain of gems and community and code being ready for the kind of constraints that Raptors have. Does that answer my question about the take on Raptors for concurrent stuff? Yeah, yes. It's useful if your problem is both greenfields and kind of doesn't rely too much on mountains of community gems. All right. I'm gonna walk through the takeaway slide and then I'll sit here and talk more if you want, but like I feel like I should give people the opportunity to leave on time if they want to. So what do we want to take away from this very long and rambling talk? So I think if we go back to our original markdown document here of everyone's thoughts on what a fiber is, what I hope is that everyone leaves with the idea of a fiber as a suspendable and resumable computation. I reckon that's a good definition that helps you understand both the use of fibers in things like enumerators, the use of fibers for things like punching blocks open and stealing their contents, but also what I think most people want to actually use fibers for now, which is writing concurrent programs using something like async. So that is, I think, fiber. And the reason why I think this is good and a much better approach to async IO than is available in other languages is because you just use the same libraries, right? There's no bifurcation of like event machine HTTP versus Faraday. It's like, no, the same gems will work with any setup. You don't have to worry about async functions and not async functions. Just all your functions behave the same. Someone said Go routines, right? So you said Go routines. So Go routines and fibers are very similar. They're both stackful coroutines in that sense, where they, you run many of them on one thread, and the runtime switches between them in the same way the fiber scheduler does. The Go routines are more advanced for two reasons. One is that they can migrate between threads. So this is critical if you want to write multi-threaded code that makes good use of all your CPUs. Then you need your Go routines to kind of go to where the free CPUs are. So Go will like migrate your Go routines between threads. And the other one is that in Ruby, those raptors, those fibers will only pause and resume either because you did fiber.yield or because you did IO. Whereas in Go, the compiler kind of liberally sprinkles some points where it like says, maybe we should yield here. So that kind of makes the fibers feel more like threads where at any time it could stop running and something else could run. That means that kind of good in the sense that if you have like, CPU intensive work, you won't get huge latency spikes, but it does mean that you need mutex and stuff in Go. So that's kind of, I think fibers and Go routines have a very close relationship, especially in terms of how they're implemented, even though in practice, because the compiler sprinkles lots of yield statements throughout your code, Go routines feel more like threads. Yeah. All right. I think nothing more in the chat. You are free to go, but I'm happy to sit here and ramble more if you want.
My question.
Yes.
Do you use scheduler for database queries as well? Like, have you used it?
So me personally, no, because of what I said, where MySQL 2 gem doesn't support async because all of its IO is done in C, in a C extension, where Ruby can't see it. So the fiber scheduler can't switch. When we, I mean, some people are in the process of trying to get all of this monolith onto Trilogy, which is, it's not happening tomorrow, but eventually that would be nice. And at that point, it is something we can consider. Yes. Ryan was talking to me about this yesterday. That is it. Yeah. So they basically unwound the Postgres gem. So libpq, the Postgres C library, is much better than libmysql client. libpq has APIs that are like, they let you own the file descriptor and pass the file descriptor to libpq and say, run a query. And then libpq will be like, well, I half did it, but I'm waiting for this IO to finish. Please call me again when it's done. So that allows, then the PG extension can take that file descriptor and tell Ruby, okay, I'm waiting on this. So there's a function in the Ruby API. Yeah, so you can, if your C extension can call this, RB wait for single FD, and then that tells Ruby that, this fiber is waiting for this file descriptor, and this can end up calling to the fiber scheduler. So yeah, PG is just better than MySQL client.
Really just the fiber key.
Oh man. He gave actually an even better talk at Ruby Kaigi a couple of years ago, where he kind of walked through the history of why he started working on fibers. But at the risk of butchering his excellent talk, and talking about the man behind his back. Sorry?
Just go watch it.
Yeah. He wanted to write a DNS resolver for his home network, and he wanted to do it in Ruby. And for some reason, he didn't want to do it with threads. And then he's like, oh, well, I use Event Machine, but it sucks. And then started the mother of all yak shaves, which culminated in getting the stuff merged into Ruby. And
Finish writing his DNS thing yet?
I actually don't know. I should ask him.
What do you think is the advantage of having multiple fiber schedules? Like not having multiple at the same time, but more have the different implementation. Even all of them will be almost identical.
That is an excellent question. The question is, why have multiple fiber schedulers? Like, why have an interface for fiber schedulers rather than just having a fiber scheduler in the Ruby standard library?
Different criteria of which fiber to run next.
Yes. So you could imagine different algorithms for choosing what fiber to schedule. I'm kind of torn here. A lot of the complexity in the fiber scheduler is dealing with operating system related gunk about like how to glue IO uring, KQ, epoll, etc. to Ruby's IO model. And I don't feel like there's a lot of differentiation in there. But I know Samuel was pretty keen to make this an interface, that he wanted there to be some experimentation in this space. And I saw him on Slack the other day. He like found someone had implemented some hype. Let me remember what it was. I just I'll find it. But there was someone made another fiber scheduler implementation as part of some project to like make a high performance Ruby web setup. and he was really interested that like, other people are taking this and doing different things with it. I don't know, maybe in Ruby 3.5, like they say, mission accomplished, we're going to fold it all back in, and there's a blessed fiber scheduler. But that's really kind of going against the grain of how Ruby is going, which is pulling gems out of standard library. They could ship a very small default one, which worked by using IO select. And I think I saw someone wrote like a 200 line fiber scheduler, which is basically uses Ruby's built-in IO select mechanism. I mean, it wouldn't be very high performance. And then the question is, if you need literally any other gem in your program, then you may as well also install the async gem. Like the gem story in Ruby is so good compared to other languages that I'm not really sold that like using gems in Ruby is way easier than dependency management in most other languages. Like even for one-line scripts. Do you guys know about bundler inline? Yeah, right? Like super useful, and there's nothing useful similar in like Python or Go. So because it's so easy to use gems in Ruby, I feel like the impetus to put a default implementation in there is kind of not there. Busy making this shit.
Is there much of a sort of need to interface directly with fibers when you're using the async library, or is that
Not at all. I don't think you should type the word fiber literally once.
Do you still yield, or is that like?
No, I think you generally don't want to be using yield, because if you're yield, that means you're returning. But the question becomes, what are you returning from? Because remember, you were transferred to, you were go-to'd into by the fiber scheduler. So returning from a go-to doesn't make a lot of sense. All right, I'm getting kicked off. Yeah. Let's continue this afterwards.